One.
So we'll continue with new topic, storage basics. So this is not part of our index, but still to understand our storage topic better, we need these basics. Okay, so before we enter into storage topic, the basic thing that we should know is file system. File system is basically called kind of language for us to communicate each other. It's a file system for a machine to read and write data on a particular hard disk. Okay, if there is a computer, just brand new computer, laptop or desktop, server, virtual machine, whatever it may be. Okay, it will have one hard disk connected to it. Now, if you are trying to install Windows operating system, this disk should be formatted in Windows understandable file system. If it is a Linux, the disk should be under the disk layout, the format on this disk should be understandable by Linux. Anyway, any other operating system, if it is a physical, virtual, server or client, doesn't matter. If it is operating system, the disk should be formatted with some file system. Okay. So for Windows operating system, there is known file system, old file system, and new file system. Okay. So the old file system, if it is a Windows operating system, the old file system is called FAT, File Allocation Table, older one. And newer file system is called NTFS, New Technology File System. Okay, New Technology File System. If you are attaching a disk to a Windows machine, or if there is a hard disk when you are trying to install Windows operating system here, anything, server or client, it will format the hard disk with its understandable file system, FAT or NTFS, both it can read and write. The C drive and D drive, normally it will be formatted with NTFS. If you see, already this is a Windows machine, right? So D colon, right click, properties. If you see file system, NTFS. The D drive, the 350 GB hard disk, is formatted with NTFS file system. That's why if you log into this disk, you can see what is the content inside from a Windows machine. Okay. If you see nowadays also, if you attach any pen drive to a Windows machine, it will be still formatted with FAT, file allocation table. If you attach a pen drive, just touch it, just check here. Once you attach a pen drive, just go to properties. You'll see the file system as FAT 32 or 64, whatever it may be. That's just architecture. FAT will be there here. When you are formatting also, when you right click, format, so here you get option to select NTFS or FAT. But if it's an internal hard disk, right? We get only NTFS is the supported one. If it is a pen drive, when you right click on format, here you can change FAT versus NTFS. Anything that you can select. And click on start, it will format the disk. Okay. But C drive and D drive by default itself, when you install OS itself, it will be formatted with a NTFS file system. So Windows machine can read and write data with a disk formatted with NTFS file system. Clear? And now, if you have two Windows machines, this is also another Windows machine. And if you want to connect directly together, older days it was not possible. Single hard disk, you cannot connect them together. Same hard disk, it's not possible to attach it to two Windows machines like this. It's not possible. Then for some reason, if you want to share this hard disk between these two machines, what we do, we connect these two computers in the network, and via this path, it can go and access the data. But in this case, the first machine 1 will have full access to this disk. Let's say it is formatted into D colon. From here, if you want to change, you can change into E drive, F drive, whatever it is. Format everything, place new data, delete anything it can have. But the second machine will have limited access. Second machine will not have full access on this hard disk. Here, only first machine will have full access. Second machine will have limited access. That also we need to provide permissions from this computer. So let's say you access this part of the data from this computer. So that permission we will give it from this machine. Okay. Whatever the permission we have given from this computer on portion of the disk, it will access. That means only limited access it can get. So it's not possible to get full access to this hard disk. If you want to change from E drive to F drive, from here it's not possible, from here it's possible. That's what I'm trying to say, full access versus limited access. So disk sharing is not directly, it's not possible. If you see same procedure on a Linux machine, this is for Windows machine. If it is a Linux machine, the older file system is ext3, extended file system, and newer file system is ext4, extended file system. So if it is connected to one machine, so via another machine only it can connect one Linux to another Linux. This is a hard disk. Directly it is not possible to share, so via network we have shared. Same way. Okay. Now I have attached a hard disk here, formatted with ext file system from the Linux machine, and placed some 5 GB of data also here. Formatted with extended file system and placed 5 GB of data on this particular hard disk. Now, if I remove this hard disk from here and if I attach to this Linux machine, do I need to format again or can I see the data directly? No need to format it, right? Sure, right? And let's say same hard disk, if I attach it to any Windows machine, no need or need? Need to format. From remote. So I have attached a hard disk to a Linux machine, formatted with ext file system, and placed some 5 GB of data, whatever, movie, personal data, residuals, whatever it is. Place some data here. I have disconnected this hard disk and attached it to Windows machine directly. Can I see the content directly or do I need to format again? If you format, what will happen?
Format again, sir.
Sorry?
Format again.
Okay. Yes. No. Need to format because this is a new file system, right? This cannot understand. As I said, it's kind of language for us. Okay, file system for operating system. So you don't know Korean language, some basic example. Okay, so you don't know the Korean language. If I give you a textbook written in Korean language, there is some content which is written in Korean language. As you don't know the language, you'll not be able to understand. The same content, story is same, but written in English or your native language, whatever it is, which you know, okay, how to read and write. So let's say English. Okay, if I give the same textbook, same story written in English, okay, you can able to read it because you know the language. Same content earlier you are not able to read, now you are able to read it. Here also the same thing. If the disk is formatted with ext4, if you attach it to a Windows machine, this machine cannot understand what is this ext4. Okay, so it will ask you to format, then only it can place new data. If you format this data, we will lose. Okay, so that just basic understanding. Right? That was the situation with Windows and Linux before VMware came into the picture. Okay. Now, once VMware has started their new company, they have developed their own file system called VMFS, VMware File System. They have developed their own file system called VMware File System. Older one. It depends on version to version. If it is vSphere 6, you are using ESXi 6, VMFS 6. If you are using ESXi 7, it will be VMFS 7. It depends on version to version. All vSphere 6 versions, 6.0, 6.5, 6.7, all uses VMFS 6. ESXi vCenter 7, ESXi 7 will use VMFS 7. Clear? Now, so because there were some issues, or maybe it was not expected, the way NTFS file system or ext file system, which were there already in the market, they did not like it. They were aiming for some other different architecture, and these existing file systems did not help them. So that's why they have developed their own file system called VMware File System. Okay. Now you have two ESXi machines, ESXi 1 and ESXi 2, and you have a hard disk here. Okay, it is possible to directly connect two ESXi machines to the same hard disk. Okay, this is one single hard disk. Both machines you can connect at a time together, and both machines, either from here or from here, you can format this disk with VMFS file system. Then only these ESX machines can read and write the data on this particular hard disk. If they format with VMFS, then only they can read and write. Remember this sentence: if it is formatted with VMFS, then only ESX machine can read and write. Okay. Now, from here also, ESXi 1 also, you can have full access. From ESXi 2 also, you can have full access. That's how this VMFS file system was designed. Here we have formatted with VMFS file system. This VMFS file system will allow multiple machines with full access directly to them. This hard disk, both machines can read and write with full permissions. From here also, if you want to format, you can format. Again, with the data or without data, if you want to format. From here also, if you want to format, at any time, you can format. That means both has full permissions. Not only 2, it's up to 64. 64 ESXi hosts can have full permissions on a single hard disk at a time. We'll see. Okay, why 64? That reasons later. Clear? So with this, multiple machines have full access at a time. There are a lot of benefits they have designed based on this concept. Earlier, with this model, They were not able to achieve the benefits they want to provide. With this new architecture, new file system they have designed, it allows multiple machines with full permissions at a time. So based on this concept, lot of features they have developed on top of this vSphere versions. Okay. Something very quick example. Let's say here itself. Okay. Something like here. You have placed some data here on this machine. For some reason, this machine is corrupted. Okay. To retrieve this data back, whatever the data that is presented inside this hard disk, now you cannot directly access from this computer. You have to fix this problem to bring it up. Until then, it will not come up. Whatever the important data that is available here, you cannot access from this machine. Even though this is available, the one which we are giving permission from here is not accessible, not available. Okay. If you see something like here, let's say you have placed a virtual machine here and .vmx, vmdk files and all here. Virtual machine files are here. For some reason, if this host is dead, quickly using these files, you can bring this virtual machine here. Even though there is a problem with ESXi1, you can quickly bring the virtual machine which was impacted here. Quickly you can bring it here because this second ESXi host has full access on this hard disk. So it will take ownership of these files. The VM will come from here, will come to this location. Now, even you have not noticed there is a problem, the machine is up and running. If it was like this, until you fix this problem, you will not be able to access that data. Here, even there is a problem, even you have not identified where the problem is, the virtual machine is available and running from here. So those kind of benefits that we will go about these benefits later. Okay. Those kind of benefits they were able to achieve with the help of shared storage. This is called shared storage. Because hard disk storage space is shared with full permissions. Right? So it's called shared storage. Based on shared storage concept, they have developed a lot of benefits for the customer who use this technology. We'll discuss all those benefits later after the storage topic. If you have any questions, let me know.
Good morning, Durga.
Good morning.
Can you show that screen, please? Okay. Yeah, Tiger. So in VMware, we have a ESXi, one is running on 6 version and another one is running on 7 version.
Okay.
If suppose if you format the hard disk with EMFS 6 version, can it possible to read the 7 versions of ESXi files?
Yeah. So very valid question. So there is downward compatibility is available. So in this case, this disk is formatted with 6. So ESX6 definitely can access it. Okay. And 7, it can access 6 also. 7, it is compatible with VMFS 7, 6 also. So it can read and write from VMFS 7 data partition and VMFS 6 partition also. And this ESXi host, it can read with VMFS 6 and 5. But 7 cannot read from VMFS 5. It is mandatory to upgrade from VMFS 5 to 6. So ESX 7 can read and write from VMFS 7 and also VMFS 6 storage partition, this hard disk. And 6 can read and write from VMFS 6 and 5. So to answer your question, yes, with respect to the numbers that you said. Understood? Is it clear? 7 can read, 6 also. But
yes,
if
yes,
it is 7, yeah. So for some reason, if it is VMFS 7, 6 cannot read. Higher version is not compatible. ESX6 cannot read and write from VMFS 7 version. Okay, so higher version is not compatible. Lower versions are compatible, but still there is a limit. 5 cannot be read and write by 7, ESXi 7. that we can, you don't need to worry about it like when we have a version here. Okay, so even though we have vCenter 7, right now this vCenter is 7. Where is it? So here, 7, but ESXi host is 6.5. So here while creating storage, there is no partition. I'll show you that how to format. Well, we are going to that topic, we'll see. Any other questions? Clear? And now we'll go to ESXi storage. So no need of this diagram. For your quick understanding, I told you this is a, let's say this is a physical server. It has some amount of RAM, let's say 100 GB RAM and Xeon CPU. Here normally it will come with very less capacity hard disk, 276 GB hard disk. Okay, so here it's called local hard disk. Local means internally connected to that physical server, okay, locally connected to that machine. So for your quick understanding, I told you when you are creating a virtual machine, a folder will be created in the local storage. And this is a virtual machine. And here .vmx, .vmdk, .nvram, all these files will be created inside this folder, right? For your quick understanding, I told you like RAM, CPU and hard disk, everything will come from this ESXi host. This is ESXi. Yes, RAM and CPU, it will get from here only. Whatever the RAM and CPU that you allocate to the virtual machine, let's say 8 GB RAM and 2 CPUs. It will get from here only, not the hard disk. Whatever the 100 GB hard disk that we allocate for this virtual machine, we can take it from local hard disk, but we will not take it. We will not allocate here. It's possible to allocate. If you place it, we will not get the benefits like what we discussed just before shared storage. That we will see later. So we will not place the virtual machine hard disk here. Let's say you want like 500 GB hard disk to this virtual machine. There is only maximum 276 GB only. Then how can we allocate 500 GB disk to this machine? So we don't use this local hard disk to store virtual machine. So this will not be placed here. So this local hard disk 276, whatever it may be, it will be used to just install the ESXi OS. Only ESXi OS will be there in the physical server local hard disk. It will take maximum 2 GB only. 276 GB even not needed. But still, the physical server's minimum disk will be this much. Okay, 276 GB, 512 GB and all. Remaining like 274 GB will be wasted only. Okay, we will not use, simply will be sitting idle. Then where will we store this virtual machine? For that purpose, there is a different technology called SAN, Storage Area Networks. It's like your internal hard disk is full, 270 GB or 512 GB. Internal hard disk in your laptop is full. You can't delete the data, all is important for you. And you want to store some more data. What you will do in this case? Buy an external hard disk. Okay, here also it's something like this. It's an external hard disk for our company, but very huge. Our personal external hard disk will have 1 terabyte or 2 terabyte maximum. Okay, so here it will be depends on company. Next 3 to 4 years need, it will be 100 terabyte, even more. 100 terabyte is very simple. Even small company, it is not enough. If you see enterprise level companies, will be available even petabytes. Okay. Depends on next 3 to 4 years need, they will buy this one. External hard disk. Right now, it's called remote. I mean, we'll go to the basics. Let's say this is 500 terabyte capacity. There will be a separate team who will be handling this part. It's a separate technology. You need like 1 month to learn this technology. And you don't need to worry to get a job. This one technology, what we are learning is enough for now. Okay. This is a new technology completely handled by a separate team of people in day-to-day work. Okay. And here, separate team, they will create partitions inside this hard disk. Like this. And this will be depends on our standards. We can say 4 terabyte, 6 or 8. Okay, let's say 6 terabyte is the generic capacity used. One partition will be 6 terabyte. Altogether makes 500 terabyte. Like this. Each partition they will create 6 terabyte. And this this storage 500 terabyte external storage is attached to the ESXi machine. Now ESXi machine will look at this 6 terabyte partition. Is this 6 terabyte will be visible from the ESXi host. And we have to format with which file system? If you want to read and write data from the ESXi machine, what should be the file system on this hard disk?
VMFS.
VMFS. So this hard 6 terabyte space, hard disk space should be formatted with VMFS, VMware file system. Once it is formatted, while creating a virtual machine, we can see 276 GB VMFS partition and 6 terabyte VMFS partition. Both will be visible. So we don't place any VMs on local hard disk. We always place it here. If you select this 6 terabyte partition while creating this virtual machine, it will be placed here. Okay. And once you place, all these files will be created inside that partition. VMX, VMDK, NVRAM, all will be inside the folder. Now, once the VM is created, if you power on this VM, RAM and CPU, it will take it from the ESXi available resources, and the hard disk, it will take it from the remote storage. Now, up to 6 terabyte, you can use whatever the disk space that you want. You can allocate 500 GB, 1 terabyte, or let's say for this machine, you want to allocate 2 terabyte. The second machine. So you can create, it will occupy from this partition. Okay, up to 6 terabyte you can use. And after that, one more partition, it will go, continue. So RAM and CPU it will get from the ESXi, hard disk it will come from the remote external storage. Understood? In real time we use this concept, not on the local disk. Clear? Any questions from remote? Yes, Akbar, if you format a storage disk from ESXi 7, it will be formatted with, again, there is something you need to think about. When you are formatting from 7.0, you have option to format. So he is saying my ESXi is 7.0. This is the ESXi version is 7.0. I'm trying to format this hard disk partition. While formatting with VMFS, you will get two options. You want to select VMFS 7 or 6. You can select this option. It's choosable. You can choose any of the option, VMFS 7 or 6. For some reason, if you select as VMFS 7, and if you have another ESXi host, this is also formatted with, this is also ESXi 7, and this is ESXi 6.0. If you format this partition with VMFS 7, you can select 6 versus 7. You selected 7. This ESXi host and this ESXi host both can see that partition. First, it's possible to choose 6 also. If you choose 6 also, it will be visible from all the 3 hosts. So it depends on, while formatting the disk, it depends on which file system that you select, which file system version that you select. Yes, RAM and CPU, virtual machine will get RAM and CPU from the ESXi host, and hard disk, it will come from the remote storage. Clear? Now, so just for a brief, like I have mentioned with a single line, we'll see technically what are all the components involved here. So we have our ESXi server here, physical server. This is our ESXi. So these are the adapters which are specially made to connect to this external storage. Called, in generic word, I will use storage adapters for now. There will be a specific name later. Depends on storage model. Storage adapter 1 and 2. These adapters are specially made to connect to the external storage. And these are storage switches. Storage switch 1 and storage switch 2. So it is also, these switches also specially manufactured to send and receive storage traffic from ESXi machine to the external storage. Clear? These switches are specially manufactured to send only storage traffic from the ESXi to the external storage system. And this system, this box, the external storage box, so technically it's called SAN array, storage area networks array. So from now onwards, we'll say SAN array or just array. Okay, storage array. So from the ESXi machine storage adapters, a cable will be connected to the storage switch 1 and adapter 2 to the storage switch 2. It's for redundant connectivity. In case of any problem in path 1, still we should not lose access to the storage array. So from storage switch 1, it will be going to the adapter on the storage array, and from here it will be going to this one, and here also it is redundant from here, and from here it will be connected. So from the ESXi machine to the SAN array, everywhere it is redundant. In case of just a cable problem, should not cause any storage disconnections. That's why we have another path. Clear? So not only this cable, this adapter, this switch, this adapter should not cause any single damage, should not impact the connectivity. Okay. Still we should have second path to reach the destination. Here, these are called storage controllers. The adapters we call storage adapter, right? The adapters on the storage array called storage controllers. Storage controller 1 and normally A and B. Storage processor or storage controllers. Processor is the old name, controller is the new name. It will have operating system. Storage controller will have small OS to control this data on the SAN array. This entire array, as I said, it will be depends on our company. Next 3 to 4 years needs, let's say 500 terabyte capacity. It will have internally the same like external hard disks we have, right? Personal 1 terabyte or 2 terabyte external hard disk. So like that only, multiple internal hard disks connected together. Each one may be 1 terabyte or 2 terabyte. If it is 1 terabyte, 500 hard disks like this will be connected together. If it is 2 terabyte, 250 hard disks will be connected together, makes 500 terabyte together. The same like our internal external hard disk, 1 terabyte or 2 terabyte external hard disk, it will be connected here all together in a single box. It's called SAN array, and here also there will be redundancy anywhere from the controller to the hard disks. Clear? Single 1 terabyte or 2 terabyte disk makes total 500 terabyte. I'll just draw here. Like this, connected together in a single box. Fine. So specially made adapters on the physical server backend we can notice to connect to the storage switches, and storage switch to the storage controllers on the SAN array will be connected in the redundant manner. And in real time, our job will be up to this portion only. And storage team will take care of this portion, storage array. And data center team, the person who is available in the building, secure building, data center, right? They will take care of these connections. We will just tell them ESXi1 to which storage switch it should go. We will just give him the numbers. He will go and connect the cables accordingly. So clear as of now how it is connected. Now, once the physical connectivity is done, if anyone has question, you can type or you can interrupt me and ask. Okay, anytime you can interrupt. So from one physical server, it will be connected to the storage array in redundant manner using all these components. Now, these are physical connectivity is done. Now ESX machine cannot see the storage, even though if it is physical connection is completed, it's not visible yet. Then we have to talk to the storage admin who is working on this system for the connectivity. There should be some logical configuration also should be done. Okay, physical connectivity is done, then logical configuration. For that, we will inform the storage team. Hey, I want 2 into 6 terabyte partition. That means 2 partitions, each one of 6 terabyte capacity. I need 2 6 terabyte partitions from your storage array to this ESXi machine. Then what he will do? He will log into its storage system, and he know how to create a partitions here. He will create 2 6 terabyte partitions. Like this. And he will logically present to our ESXi host. We'll see what are the technical work will be involved there. So now storage team created 2 partitions of each 6 terabyte capacity, and he logically presented these partitions to our ESXi via the storage systems. We'll see what is the technically called. Okay. So his logical configuration is also completed now. Now from this ESXi machine, I can see 2 6 terabyte partitions which are configured on the SAN array. This, okay. Clear? Now, while creating virtual machine, now in this situation as of now, logical configuration from storage team is completed. Okay. Can I place virtual machine directly? No. Here. It's visible. 6 terabyte partition is visible to the ESXi. While creating virtual machine, can I place it here? It's just visible. It's a raw hard disk. Yes. We need to format it. Okay, that we will see. So before we creating a virtual machine on this 6 terabyte partition, we have to format with VMFS file system. then only we can place. That will be our work in day-to-day job. We have to format this partition with VMFS file system. Then you can place virtual machine here. And here it will have one local hard disk. This is called local hard disk because it is internally connected to this machine. And it is somewhere coming from a different location, right? It is not this SAN array, even though it is connected directly, but it is somewhere else, not locally within this server hardware, right? That's why we call it as the remote storage. This is local hard disk. Local storage or local hard disk, remote storage, or in day-to-day job, people call it as remote storage or shared storage. That we'll see anyway how it comes there and all. Fine. Any questions? No questions? Okay, good then. Okay, this is another ESXi host, same like ESXi1, it is ESXi2. Now, this ESXi is also connected to same storage switches. We can connect multiple servers to the switches. Switches work is to group multiple devices together. We will see how a switch looks like, how many cables we can connect and all, we'll see that. Let's say two ESXi hosts connected to the same storage switches, and from this ESXi1 we have already formatted two partitions with VMFS, right? Two partitions are formatted with VMFS. Now, once I connect the second ESXi host, we have informed storage team to logically connect the storage. They have done logical configuration also. Physical connectivity is done. Logical configuration is also completed. Now, these two VMFS partitions, can I see directly from two, or do I need to format again? These two partitions.
It's already formatted.
So can I see directly, or do I need to format from here again?
Let's see that.
Direction. This is also yes, ESXi1.
Okay. So they will be visible because they are already formatted with VMFS, right? It's like you have a pen drive connected to your laptop and you formatted and placed some resume. Remove it and attach it to another your friend laptop. You can see that resume, right, from that pen drive. Same, exactly the same, because it's been already formatted with Windows Understandable file system. Here also the same. It is already formatted with VMFS file system. So from the second system directly you can see them. You don't need to format again. Okay? Any question from remote? SP or SC will be there, older name, storage controller, SAN, storage area networks, and this 6 terabyte partition. Let's say these two are filled. We will ask storage team to create one more storage partition. He will create one more 6 terabyte partition, right? This 6 terabyte partition, normally before VM, like this partition, they call it as LUN, logical unit number. The storage team, the raw partition which is created on the SAN array is called logical unit number, a raw partition, and SAN array, storage array. Okay. LUN, logical unit number. So the storage, the partition, raw partition that they created without any file system. Okay, it's called LUN, logical unit number. There is no file system on top of that LUN. Now, from ESXi machine, we are trying to format with which file system? LUN, we will format with which file system from ESXi?
VMS.
VMFS. Once you format any hard disk with VMFS file system, it's called data store. LUN formatted with VMFS file system is called a data store. Even after formatting this LUN with VMFS from our ESXi host, we call it as data store. Still, from the storage array, they call it as LUN only. LUN 1, LUN 2, LUN 3 like that. They call it as still LUN, even though if it is formatted with VMFS, from the storage array, they call it as LUN, and from our ESXi host, it's already formatted with VMFS, right? We call it as data store. It's not a new word. It's a, if you split and see, store data. So we are trying to store some of our virtual machine data. We are storing it here. We are storing virtual machine data here. So that's, they just named it like this, data store. Storing virtual machine data. Okay, that partition they call it as data store. Data center is different, data store is different. Many people during learning stage, like current your stage, right? So people will be confusing with the data store versus data center. Data center is a physical building or this virtual icon. This is data center. Data store is the hard disk space which we formatted with VMFS file system. Okay, it's called data store. If you select ESXi host, there is a separate tab called data stores. Click here. Here you can see each partition that you formatted with VMFS. Here you can see one is formatted with VMFS 5, another one is formatted with VMFS 6. Clear? Because it is host 6.5, it supports older compatibility, downward compatibility. 5 also it supports, 6 also it supports. Clear? Whichever we have already formatted with VMFS, that you can see from here, even local plus remote, all together will be visible here. This one, first one, 271 GB is the local data store. Okay, that another one is remote one, which is coming from storage array like this in our lab. In our lab, local disk is having 270 GB, remote storage very less space, 100 GB only. Okay. It's possible to add more space, but I'll ask them to do that. Clear? Any questions from here? SAN array, LUN, data store.
Durga, good morning.
Good morning.
My VM machine is running on one particular ESXi.
Okay.
If suppose that VM ESXi is not working, so that VM is migrate to another ESXi, that particular ESXi is running in another LUN system. Suppose LUN 1 and LUN 2.
Okay.
So that time my VM which is running on ESXi1, the data which is stored on LUN1, the data also shift to LUN2. If suppose,
Okay.
can you get my point?
Let me number it clearly so it will be clear
Yeah,
for
yeah.
everyone. Okay. There are 3 LUNs, LUN1, LUN2, LUN3.
Yeah.
And there are 2 hosts, ESXi1 and ESXi2.
Yes.
So we have created a virtual machine from ESXi1, VM1, and that is placed in LUN1.
Yes. Yes.
Okay, VM1. Okay, it's placed here now. And now this ESXi host, ESXi1, can see LUN1, LUN2, and let's say LUN3 also it is visible. And now you tell me on ESXi2 which LUNs are visible? All 3 or any one?
Yeah, yeah. Now I got the answer. And my question is that suppose VM1 is placed on LUN1 only, no? So that ESXi1 is not working. So that my VM1 is shifted to ESXi2.
Yeah, coming to that point only. Now, like before that, I need confirmation here. So LUN1 is visible to the host 2 or not? No, I'm just asking, like whatever it may be, your
Yes.
concern. Visible, right?
Yes, yes.
There will be a different answer. If it is visible, different answer. If it is not visible, different answer. That's why I'm asking before itself. So let's say L1 is visible here as well, second host. Now, if host 1 fails, we are very far away from this scenario. What we are discussing, we will discuss after 3 weeks. I think 2 weeks, after 2 weeks, but still fine. We will briefly discuss now. If ESXi1 fails for some reason, if it's not working, VM1 now it will work from ESXi2. Automatically it will work. There is a feature for that to work automatically. It will come automatically like this, because L1 is visible to ESXi2. If L1 is not visible, you're clear, right, as of now? If L1 is visible here to the ESXi2, this VM will work from here. Okay, for some reason, let's say L1 is not visible here, L2 and L3 are visible, but the VM is stored in L1. If a host 1 fails, the VM will not come here. It will be here only and it will be down. Until you fix this problem, it will not come up. Understood? It will be in LUN1 only. It will not come to the ESXi2 because L1 is not visible to the host.
Okay, Durga. Understood.
Yeah. And there are workaround methods. Now, let's say just for the continuation, if you understand how to bring it up quickly, let's say this host will take 1 week time to come up. Let's say motherboard replacement you have to do. Until then, VM1 will be down. But customer is forcing you to bring my VM1 quickly. Okay, so in that situation, you tell me what you want me to do with the available options here. We can bring it here quickly. Tell me what you want me to do now. How is it possible to bring here? Just think and let. No, if it is disconnected, it will not be visible. And someone said like OVA, it's not possible because the ESX1 is disconnected. When it is disconnected, VM also will be disconnected. To export as VM, as a OVF, that should be connected. If you right click, template, export a OVF template, it should be connected. If it is like this, it will be like this. If the host is not working, it will be like this, disconnected state. It's going on, just a moment. It's not possible. It will be in unmanageable state. You cannot export as OVA. Look at this diagram, and if you want me to like,
Hard disk is connected.
Which hard disk?
Actually, it's the storage which is connected with each other.
Mm-hmm.
From any data from L1 can be shifted to LUN1 can be shifted to LUN3 through hard disk.
But to see the LUN one is not visible from the host 2, right? You have to just think little bit behind the box. I mean, beyond the box.
So actually, రెండు సేమ్ ఫార్మాట్ కాబట్టి EXI2 నుంచి LUN1 కి కనెక్ట్ చేసుకోవచ్చు. అది హార్డ్ డిస్క్ హార్డ్ డిస్క్ లాగా ఉంటుంది సార్. అదే అనేది హార్డ్ డిస్క్ కాబట్టి ఆ మిషన్ EXI1 వర్క్ చేయకపోయినా కూడా 2 తో కనెక్ట్ చేసుకోవచ్చు.
Yes. So we have to talk to the storage admin. Inform that can you connect L1 also here to the L2,
Yes.
ESX2. That's what the require we have to do. Ask him, can you connect L1 also to this host? He will make it connect. Now L1 is visible from the ESXi2. We can manually bring this VM because all the files are here, right? So using these files, we can bring the VM here.
So LUN1 LUN2 merge అయిపోయి
Not merging, separately only. It will not merge. It will be as a separate log, like this. Yeah, like this only. This separate partition. So when the host is not working, it will be like this. We cannot export as a temp OVF. It's not possible. Okay? It like only separate partition.
యాక్సెస్ మాత్రం ఇస్తాం.
Yes. Clear? Yes, that's what I said, Venkat. You are correct. Not vMotion again. This is something wrong. Until first one is correct, and then manually we have to bring that VM. We'll see that situations later. At least you have to just get this idea. L1 can be connected to host 2. Then manually we can bring this VM here. Okay, that's fine. Just to test your thinking. Any other question here?